Okay, so in this video, we're going to be talking about carbon and what carbon's all about. So carbon has 4 valence electrons. Remember, if a molecule has carbon in it, then it is an organic molecule. Okay, so this is the basics of organic chemistry. So carbon has 4 valence electrons. So because of that, it can form 4 covalent bonds. Remember, covalent spell. Let's just cross that off. C-O-V. Remember, covalent bonds are the strong bonds, so they form some serious bonds, okay? And it can form actually single bonds, or double bonds, or even triple bonds with those bonds. You can make really long carbon chains from carbon, because carbon can bond to itself. And the cool part about the carbon chains is they can be straight. We'll see some of these examples as we look at some of the different groups. We can have branching, and we can have rings, okay? Carbon forms something called isomers. And an isomer means that it has the same chemical formula, but a different shape. So for example, C6H12O6, many of you are probably saying is glucose, which you are correct, but it is also the chemical formula for fructose and galactose. And we'll look at how that works when we look at the sugars or the carbohydrates. But basically, these all have the same chemical formula. They have 6 carbons, 12 hydrogens, and 6 oxygens, but they have different shapes. So same formula, different shapes. Now, what attaches to carbon and the different groups that attach to carbon are called functional groups. And these are not carbon-based things, but this is part of organic chemistry. And so you guys have to know these. You have to be able to recognize them in a molecule. So the first one is an hydroxyl group, or OH. This is also known as an alcohol, okay? And the properties of this is that if you look at it, it's got an oxygen, so that means that it's going to be polar. So that means that it's water soluble. Okay. The next one that we can look at is what's called a carbonyl group. So carbonyl. And a carbonyl is when you have a double bonded oxygen. So you can have it like this. And the reason why I'm drawing it up there is because this one is what we call a ketone. A molecule will end in ONE in this case. And then you could also have what's called an aldehyde if the double bonded oxygen is on the end. Instead of the middle of a chain, it could be on the end of a chain. So this is what's called an aldehyde. And these molecules end in Al, okay? Because we have an oxygen, that's going to be a polar compound. And so if it's polar, it also means that it's water soluble. Okay. Let's look at, we have a few more, 5 more. So the next one is a carboxyl, which is super confusing because it's not that much different than the other one. And the chemical formula is this, okay? And it looks like this. You have a carbon, double bonded oxygen with an OH group, okay? So it's basically you take the 2 above, the hydroxyl and the carbonyl, and you combine them and make a carboxyl, okay? So this is polar, again, lots of oxygens, water soluble. And this is also known as an organic acid. Okay. The next group is an amino, or an amine group. And the chemical formula for these are NH2. Okay, and so you'll see it like this, N with an H and an H. Okay. You also sometimes might see it like this, with it actually ends up with an extra H, and then it's positive. Okay. And so these, nitrogen, polar molecule, so we're polar, so that means it's going to be water soluble, and these actually happen to be a weak base. Okay. Sulfohydryl is usually, for the most part, probably the easiest one for you guys to remember because it's got that sulfur in it, so guess what? It's just an SH, okay? This is really important when you get into proteins, and when you look at the proteins, we'll see it forms what's called a disulfide bridge. It can bond to itself. Well, one can bond to another, I guess we should say. Okay, so it helps stabilize that protein shape. So that's where that's important. This is another one that's easy, the phosphate group. This is obviously, phosphate group is the most important in phospholipid membranes. And so it looks like this. Lots of oxygens. Okay, those hydrogens can actually fall off and make it a negative molecule. Obviously superpolar, lots of oxygens. Okay, water soluble. This is also important in ATP because ATP is adenosine triphosphate. It's got 3 of these. So important in ATP. Okay, last one, methyl. Probably methyl is a pretty easy one to remember. It's CH3. This is the only non-polar one because if you look at it, it's got carbon with 3 hydrogens attached to it. Okay, this is the only non-polar functional group that you have to know, and it is not water soluble. Okay, you guys just have to know them. I recommend making flashcards. You have to be able to recognize them. You got to know them. Okay. So that's the gist of the basics of organic chemistry.